Okay, so now that we have an idea of how to put together the formulas for our ionic compounds just by either using the Lewis dot symbols, or we can use the quick way, which is the crisscross or the cross charge method, where the charge on the cation becomes a subscript on the anion and vice versa. Let's take a look now at how we name our ionic compounds. And again, this is just going to be our basic, really simple ionic compounds. The ones that are just made up of two different types of ions. These are going to be our binary ionic compounds. Okay, we'll see some different ones a little bit later on. Right now, these are just the simplest kind. So the binary ionic compounds. This means you're made up of two different ions, only two. So the way that we name the ionic compounds is reflective of the way that we would write the formula. So for example, we'll use a couple different ones here. Let's say I have the combination between, let's do calcium, and we will do iodine. Okay, so we can figure out the charge on the calcium ion. Calcium is in group 2, it's a metal, so the charge is simply going to be 2 plus. Iodine is in group 7, it is a non-metal, so the charge is 7, the group number -8, which would be -1. So when I put these together now to give my chemical formula, I have Ca, and then I have I2, right, if I do my crisscross. So whenever you write your formulas, your metal goes first, or the cation goes first, anion goes second. You will note that we don't have any charges shown in the formula. Okay, the formula is just going to give us the elemental symbol, and then the subscripts that give us the ratio. So we're going to name this as we see it. So Ca is calcium. Okay, we don't put calcium ion, we just say calcium. And then iodine as a last name would be iodide. Okay, so we drop the ending, replace it with IDE, and this would simply be calcium iodide. So when it comes to the names for your basic or your just simple binary ionic compounds, we can use that very simple rule. There is one layer to this that we talked about before, and that is when we encounter things like transition metals. Okay, so if I give you a formula such as the following, so if I say CO, Cl2, all right, so again, we can write the name for the formula the formula is written. So CO is cobalt. Okay, and then Cl, chlorine as a last name, would be chloride. Okay, there's one extra step you need to ask yourself, and that is this metal here, is that a transition metal, or can it form variable charges? Or can it form different charges? Okay, and chances are, if it's in that transition element block of the table, it will, which means then that we need to specify the charge. So we're going to specify the charge as Roman numerals in parentheses. Okay, so if you don't know what the charge of the metal is, we can look at the non-metal ion. So we know, okay, that Cl is always going to be a -1 charge. Chlorine's in group 7, just like its friend iodine upstairs. So we have two of these based on the formula. So times 2 would give me -2 for all of the chlorines, all of the chlorides, actually, which means to cancel that out, the cobalt here then has to be +2, right? Because overall, our ionic compounds are neutral, and that's really, really important that we keep track of that, that you keep that in mind. So +2, or the 2 itself as a Roman numeral, okay, that's going to go in as II in parentheses. So that would be cobalt 2 chloride. Okay, so for your binary ionic compounds, when we name them, the cation goes first, followed by the anion. Okay, so just like the way the formula is written. And then if we need to, we will insert our Roman numerals if the cation can have more than one charge.